Good morning, Hamburg. It's such an honor to be here at Bit Summit and kicking off the Frontend track together with you. Hello, everyone. I'm Arvin, and I'm currently working as front-end engineer at adjoe. I love coding with JavaScript and TypeScript and building data visualizations. Whenever I'm not doing that, you can find me playing volleyball, football, sometimes ping pong, and I love cat memes. You will see them later. To put this talk in context, first I'm gonna explain you what do we do at adjoe. At adjoe, we connect game advertisers to app publishers looking to monetize their audience, allowing our end users to discover new games and earn rewards with playing them. But how do we do that? We do it through our solution called Playtime. What is Playtime? Our advertisers show the ads to the users. Users see the ads, install the game, and earn rewards with playing them. How does it look like for our advertisers? For our advertisers, to be able to create these ads, campaigns, and be able to analyze its performance, we create this dashboard for them, this tool for them to analyze everything, what is happening in the whole flow. We had this product, which was really powerful, but there was a problem. It wasn't fast. So when I say it wasn't fast, I have to explain what do I mean. Here, I brought a research from Akami. If you don't know Akami, they are one of the best out there for cloud computing and providing CDNs. And based on their research, every 3 seconds of delay in loading a web page can increase the abandon rate by 53%. What does abandon rate means here? It means the amount of users came to your platform, in this case web page, to do a specific task, but they couldn't, and they had to leave your platform without completing it. Now, let's think about our advertisers. They use our dashboard to create very complex ads with so many steps, very specific targeting, and dozens of scenarios to configure. For them, it's even more riskier when it comes to this mission-critical business tool. And on the other hand, in our offer wall, the bar is even higher. What do they need is to be able to show these ads as fast as possible with zero amount of waiting. And even 1 second of waiting can translate to churn, fewer completed offers for our users, and that ultimately translates to fewer value for our advertisers, which we don't want to happen. And as you might have understand, if we can do this process completely, the value for the whole ecosystem can be increased. And with doing it completely, it will be value for both advertisers and the users. In my rest of examples, I'm going to use the dashboard more than the other project, since I'm coming from the team who is working on this dashboard. And this is where that critical work happens. We should make sure that process of creating these complex ads are seamless and fast for our advertisers. And the huge part of that is coming from performance and speed. Behind that clean interface that I showed you, we are processing terabytes of data. Our advertisers are managing huge advertising budgets, and they expect to be able to analyze this data instantly. When they click a button, they don't expect to wait. They expect to see the immediate results. That's the bar we have to meet. But it's also the time that problem happens. In some of the cases, our pages were a little bit slow to load. And even worse, in some cases, after the page was loaded, the users was waiting for a frozen screen to be able to interact with it. So, now, let's talk about performance in a little bit bigger picture. It's a topic critical to both business success and user experience. When we think about performance, most of the time we think about network speed. But as we will see, that's just the beginning. the first moment that user interacts with your web application and the first byte that they download will set the stage for everything that follows. So first byte is the first impression. And this need for speed isn't just a need. It's a critical business metric. And for reaching to it, today we are here to talk about how to optimize web performance in web pages. When I want to talk about web performance, I can categorize it in three main topics: loading performance, parsing and compilation, and rendering. But as you know, Bit Summit is only one day and we have 30 minutes to talk. So today I will only focus on loading performance. Let's see, what do we have here? I'm gonna start with one question from you. Can we buy the speed with buying more servers, throwing more hardware on client-side applications? Anybody wants to answer? Of course we cannot, unless we can buy a MacBook for all of our customers, which is very hard to imagine. Yes, it's really, really hard. That's why we, as the front-end developers, are getting paid to optimize these front-end side applications. As developers, when we are developing, we normally use a very fancy MacBook Pro with a fiber internet, but on the other hand, our users are on a budget Android phone with a congested network. The CPU is throttling under the heat, and we expect to see the same result on their end, which is most of the time not possible. That's why I always say performance is empathy. We have to make sure we are shipping less JavaScript for our customers, for our users, which means less amount of work that should happen on their end. My last slide with some numbers, I promise. Here I brought a chart which is showing the amount of JavaScript in average on all websites, web pages are being shipped from 2011 to today. Here, the number that I highlighted is showing this number 5 years ago, which was around 400 kilobytes. And if we compare it to the number above, which is today, the number is almost doubled. So the number of JavaScript bytes that we are shipping is increasing, and we have to think about how to optimize it. The first mistake that so many people does when we talk about performance is that we think it's only about network transfer. But network transfer is only the tip of this iceberg, the amount of code that they have to download to be able to run the apps. But the more amount of time should be spent on parsing, executing, and rendering this code. But there is one important thing. If we can optimize this tip of the iceberg, the amount of time that we have to spend for parsing, executing, and rendering will also drastically decrease. So we had at this point that we wanted to decide how to start. Do you think how we started? Which part of this iceberg we choose to start working on it at adjoe? Any ideas? Where did we choose? Very genius. We started with the tip of the iceberg. Actually, there were so many reasons, but the main one was that we needed some good numbers for our management to show them, to convince them that this process really worth doing it. And tip of this iceberg, bundle size, was the best thing that we could choose. So we went with bundle size. Talking about loading performance, I think it has three levers: shipping less code, delivering it smarter, and running lighter. Let's start with the first one. All the story began one day when one of my colleagues created this ticket. Investigate tree shaking issue. If you are not familiar with tree shaking, it's a process of removing unused code from your bundle that most of the time the bundler does it for you. So at this point, we had this assumption that there is something not going very well in our project. If I want to explain you a little bit more, at that time, the first chunk of JavaScript we were shipping was 3.05 megabytes, not gzipped. It's not that big at the end, but still, the number was very big. To understand the next slides better, I have to explain you how is the structure of our project. Here is our monorepo, and there we have two main applications. And for handling the common things that is happening between two apps, we have our common modules, contains authentication, UI components, utils, and so many other things. For understanding what is happening in our bundle, first we had to choose a tool to analyze our bundle. Back in the days, we were on Webpack, so Webpack Bundle Analyzer was the tool that we chose, but now if you are on Vite or Vite, you can use Rollup Plugin Analyzer. And when you did this analyzing, you will end up seeing some chunks like this. This is only one of 100 things that we had in our bundle, which is pointing to recharts, one of the libraries that we use for visualizing the data. But there was one problem. We had this library written in our common modules, but we were not using it in the main applications. So without even having it, it was part of our bundle. So we just imported, but not used it. It was part of the bundle. This was not the only case. We had also some other examples, like this one. We had some components written by us, again in the common modules, but not used in the main applications. This one was also part of our bundle. Yeah, here is where you see it's coming from our common components, but not used in the main application. So that was the point that we thought, okay, there are some same patterns happening here, and we did some deeper investigation to understand what's the problem behind, and we reached to this. We were migrating from Webpack to Vite, and as part of this migration, the whole tree shaking was not working anymore. Why it was not working? There's a attribute, treeshake.module side effects in rollup, and by default, it's set to true. When it is set to true, it always does this imagination that every modules that you are importing in your application will have some side effects in your app, and not considering they are used, they have side effects, anything, it will import, and it will be part of your final bundle. So that was the main issue. And with resolving it, you remember that 3.05? It was less, but that was not the point that we stopped. There were also so many more things we could do. One example was where we were importing some external libraries. In this example, it's coming from Sentry. We saw that we have so many cases, we are importing the whole library, but was it really needed? Answer is no in most of the cases. For example, from Sentry, we only needed some part of it. Previously, we were importing the whole thing, but at the end, we saw, okay, maybe 3-4 main functionalities that we are importing, so we ended up only having them. It was not the only example. We were also had some bigger external libraries like Lodash and others, and we slimming all these dependencies. The number was really promising. We could decrease our bundle size by 18%, from 3 megabytes to 2.5. It was already half a megabyte win for us. Unfortunately, we couldn't continue this project for a couple of months. We were shipping so many features, and this bundle size again increased by 300 kilobytes. We were at 2.8, but gzip was a little bit less, as you can imagine. We were on 800 kilobytes. This number was still double of what you imagine to have from a standard web application. We should reduce it between 300 to 400. So we were so far from the dream that we had. We asked us one question. This big problem cannot be caused by one small issue. There should be a bigger issue that we are not understanding here. What was the problem in our case? Imagine this whole project. We have so many features. In the left sidebar, you can see the features that we are providing. Each of them has their own roads. How we were doing it previously, we were shipping the whole amount of JavaScript our users needed for running this application at the first time they were visiting us, and we were expecting them to go and explore the whole features. So they were coming to only see one room, and we were giving them the whole house. So it was not true. What's the solution? You can do code splitting. We used React Lazy and Suspense, and what we do was we were importing these modules of this application on demand when user was going to it. So previously, it was one big chunk. Now it was divided by more than 10 chunks that user will download it only if they need it. And the number was much bigger this time. At the end, the number that we could reach was from 3 megabytes to 1.2 megabytes. With gzipped was 300 kilobytes and 90. It was very, very big, and we were coming closer to the number that we had in our mind. It was already a win, but there were so many other things that we had in mind that we can do. I'm going to show you a couple of examples, what more you can add to it. You can put some stuff as conditional importing in your application. It depends on the user's preferences on the browser that what they choose, and only based on that, some specific stuff like the animations and different things will be downloaded for them only if they want to. And even some more you can do is importing on user interaction. Here I brought an example that you can see here. In this example, users start interacting with our input, and as you can see, the JavaScript needed for validating that form will be downloaded only after user interacts. It was a very simple example that the amount of JS maybe wasn't big, but when you have some big components, that you have this in mind that maybe our users even won't use that component. You can do the importing by interaction. In this way, the amount of JS you will ship in the first byte is much lower. One point that I wanted to mention here is that it doesn't mean that you are just cutting these numbers and it won't going to be downloaded at the end. Everything will be downloaded when they reach to it, but the value here is that nothing unnecessary will be downloaded for them. So let's see our takeaways from this chapter. Be cautious when you are changing your bundler. In our example, we were switching from Webpack to Vite. We only trusted the documentations. We had this in mind, okay, everything will go well. But surprisingly, tree shaking was not working. Slim your dependencies. Whenever you want to import something from external library, ask this from yourself. Do I really need all the things that I'm importing, or I'm just seeing the future and I want to import more and more? Most of the time, the answer to this question is no, and you will end up importing 2, 3, or maximum, not the whole library at all. And my golden rule. If you can do it later, don't do it now. It's very simple, but it's very decider when it comes to so many decisions that you want to take. So the code splitting can be also part of it, or anytime you want to do any actions in your applications, please wait for user to ask for it. Don't have this imagination that I should prepare everything for them, and then when they reach to it, it's ready for them. Always be the laziest possible when you're writing your app. Okay. We saw everything about first chapter. Let's jump to the next one. Let's talk about shipping. For understanding this chapter a little bit better, I have to explain two main concepts first, latency and bandwidth. Okay, here we see a very normal day of my life. Me on the left side, my friend on the right side. I starting my day with sending these cat memes to him, and everybody, please imagine the purple part that we see is a wire connecting me to my friend. What does bandwidth mean here? Bandwidth means the amount of these cat memes I can stack on top of each other, and all of them are able to be sent at the same time. All of them in one package. But what does latency means here? Latency is talking about the length of this wire that is connecting me to my friend. Anything bigger this value be, the latency will be more. But there are some things that will break this game for us. Latency will dominate small files, which is most of the time in our applications, the JS files or API requests. And how we normally try to resolve these issues, the king will come here. CDN will resolve this issue. But how does CDN resolve this issue? Imagine I was staying here in Hamburg and my friend was in Japan. Normally, the wire connecting these two will be very long. So the time that these assets should travel will be very long. But how CDN resolve this issue? CDN will copy the assets that you have and will put it in different locations. And whenever user want to have access to your assets, they will download it from the closest location that they are. So the amount of time that these files have to travel will decrease. It will decrease the latency here, but also decreases the bandwidth. How does it do that? With every user downloading the assets from the edge local servers, the amount of transfer in the main network will decrease, and therefore the congestion will decrease, and this transfer will be much faster. In our case, it was making so much sense because we were customers all around the world, from here in Europe to US, APAC, China, so many different locations. And with using this solution, which we were using Cloudflare from AWS, the amount of time that our users were needing for downloading the first byte and also the rest was hugely decreasing. You remember this number that I showed you that we could decrease the 3 megabytes to 1.2? We still have to ship this small number of JavaScript to our users. But how does it happen? On internet, when you want to ship these assets to your user, it won't gonna be sent as one huge blob. But how it will look like? It will divide it to smaller packets. Let's imagine they are envelopes, and it will deliver these smaller pieces. And each of them can be as big as 16 kilobytes. So how each of these envelopes will be sent? It works like this. Then at the start, it starts with sending 1 or 2 envelopes. If it got the thumbs up from the receiver that everything is good, then all the other envelopes also flow down the road, and the rest will happen faster and faster. This process is called TCP congestion control. But on the other hand, the bad part can happen as well. It will send the first or 2 envelopes. One of them will be lost in the road. The road is shaky. It will say, I won't gonna trust you. I won't gonna send you the more envelopes. And the process of shipping these packets to the receiver will be slowed down, way slower than how you can imagine. That's the reason when you have unstable internet connection and you want to have access to a website, it's much worse than not having internet at all. That was the reason from the first chapter when we were talking, okay, we have to decrease the amount of JS that we are shipping because it will be divided to these packets, and you have to try for delivering each of these packets for your users. And when the internet is unstable, you will feel how it's more painful. So let's go to the last chapter, running lighter. The last line of our defense is caching. What do we normally do in our projects? I divided it to 3 main pieces. The first one, which is I think the most important one, is caching API request. We have React Query doing this for us, but it can be different examples based on your stack. We can make sure that when a user revisits any places that they have requested the API for it, nothing will be repeated. Everything will be cached for them, and there won't be unnecessary API calls. You can even do more with HTTP caching headers, like e-tags or header caching. So many other things that you can do. You should understand them based on your need. And the last one, which is the most powerful one, service worker. If you're not familiar with it, it's a feature from the browser that lets you do programmable caching. How you can do it and what you can do is completely unlimited. You can do so many things. You can preload your assets. You can even download everything that your user needs for having the application even working on a flight mode. So it's not only optimization, it's resilience for your apps. And at the end, after doing all these steps, we shouldn't stop here. There are so many more things that we should think about because it's not only about talking right now, but about the future. You should always keep yourself updated with the new tools coming for like bundlers to understand how they can benefit you and how you can use them integrated to your projects. So many other things like how you are streaming your HTML files. You can also think about having like server-side rendering in your apps. If it makes sense for you, if it's like kind of a website that's serving the HTML will help you there, you should also consider that one. And using the more modern version of HTTP. Most of the time, it's not in your hand. It depends on when you are hosting your file. For example, we are using AWS. We are heavily depending on AWS. And for us, currently, it's more HTTP2. And we all remember how was the win switching from HTTP1 to HTTP2. Previously, for downloading the assets, the JavaScript that user had to download, it was happening like a waterfall. The first file was downloaded, then the next one was starting after that. But with HTTP2, we shouldn't wait for it. It was concurrently happening, and all the assets could be downloaded at the same time. You remember I showed you that not very fast dashboard? We could resolve it. And from this loading bar, we reach to this lightning fast command center for our advertisers, the tool that they deserve to use it. Now I only showed you what we did for trying to ship less code, delivering it smarter and aggressively caching, but that was not the whole story what we did. Of course, there were so many other efforts in the whole platform what we did, from infrastructure to backend or even so many other things. Today I only talked about that one, but we did so many other things. If I want to only give you one example, we actually switched our database to Apache Druid, and it was also a very big win, the amount of the time that we were spending for querying this data. Now, let's summarize what we talked about in the whole presentation. Make sure that you're analyzing your bundle. You should understand what is happening when a user is trying to fetch your application and running it. I introduce you to the rules and the tools that you can use. So go ahead and do it. Second one, always try to ship less code. You will benefit in very different aspects. Don't ask me anymore. You should do it. And even when you made it smaller, still think about delivering these assets smarter to your users. And the last one, cache aggressively. Anything that you can cache for your users, do it. They shouldn't always wait for something to happen. If you can prefetch some of the routes for them or anything that can make their life easier, do it. And the last thing, first bite is the first impression. Make it count. Thank you.